Let's talk about the concentration of a saturated solution. You were supposed to only answer one blue question. It was blue question number 5. This one right here. 1's here, 2, 3, 4, 5. How would the calculated concentration be affected if some of the undissolved solid had carried over from the test tube to the dish? Well, here's the equation for concentration. It's also, so concentration is mass divided by volume times 100. Same equation as it is for solubility. Remember, solubility is just the maximum concentration. That's all that means. So let's use this equation here. And let's just look at what would happen. If some of the undissolved solid had carried over to the dish, that means we're going to have more solid than we thought we would have. And so therefore, the solubility would be greater. So this is the explanation. All right, mass goes up, your volume is going to stay the same, and the solubility is going to increase. So let's talk about the numbered questions. So you're supposed to answer 7 through 12. So number 7 says, suppose you dissolve 0.6 grams of a powder in 20 cubic centimeters of water. The solution is not saturated, meaning you can put more solid in it. You can dissolve more solid in that amount of water. Which of the following outcomes might be observed if the solution was left in an open dish for several days? Well, it's possible that some of the water could evaporate and it still doesn't become saturated, so there's still not solid left at the bottom. So A is a possibility. It's also possible that some water evaporated and there's some solid at the bottom of the dish. Because we really don't know how close this is to being saturated. It doesn't tell us. And it's also possible, depending on the humidity and a bunch of other factors in the room, that all the water evaporates, all 20 cubic centimeters, and there's only solid left remaining in the dish. So on number 7, A, B, and C are all possibilities. We just can't really tell. Number 8, it says the student poured 60 grams of sodium nitrate into 100 cubic centimeters of water and observed that all the solid dissolved. Which of the following can she conclude about the solubility of sodium nitrate in water? Well, if all of it dissolved, the solubility has got to be, the most likely answer is it's going to be greater than 60 grams per 100 cubic centimeters. But it is possible that we found the exact solubility of sodium nitrate, although not very likely. So I'm going to lightly put kind of a dashed line around letter B to let us know that B is also a possibility, but the most likely answer is C. The best answer here is C. Number 9, a solid is placed in a container with water and stirred thoroughly. Some solid dissolves and some remains at the bottom of the container. Will adding more water and stirring cause more of the solid to dissolve? Yes. Okay, because now we've got more water for that solid to go into. Does adding more water increase the solubility of the solid? No. Solubility is a characteristic property. It's like density. It is what it is. The solubility of salt and water at room temperature is about 35 grams per 100 cubic centimeters. It does not matter how much solid you have or how much water you have. The maximum you can dissolve is 35 grams in 100 cubic centimeters. Number 10, I'm going to move this up so we can see 10, 11, and 12. And I'm going to erase these. Number 10. It says, Mario wishes to construct a table that lists the solubility in water of several substances. From various sources, he finds the following data for solubilities at 0 degrees Celsius. So I'm just going to put 10. Here's the equation. Solubility is mass divided by volume times 100. And so we'll just put these one at a time. I'm not going to rewrite the equation. So boric acid is 0.2 grams in 10 cubic centimeters. So 0.2 divided by 10 times 100. Letter B, 25 grams in 600 cubic centimeters, so 25 divided by 600 times 100. Letter C, 220 grams divided by 1,000 times 100. And then letter D, 24 grams in 350 cubic centimeters times 100. So we'll do the math on those and write those numbers down. So 0.2 divided by 10 times 100 is 2. So this is 2 grams per 100 cubic centimeters. 25 divided by 600 times 100 is 4.2 grams per 100 cubic centimeters. 220 divided by 1,000 times 100 is going to be 22 grams per 100 cubic centimeters. And then 24 divided by 350 times 100 is 6.9 grams per 100. I'm going to circle those answers. Make sure you have the work, the answers, and the units. It'll come in handy on the quiz. Then number 11 says, from your answers to question 10, find the largest mass of each substance that will dissolve in 60 cubic centimeters of water. So we know how much will dissolve in 100. So 60 is 0.6 of 100. So all that I'm going to do on number 11 was we're going to do the same thing. We're just going to take the answer times 0.6. Because 60 is 60% of 100. So if we just take it times 0.6, it's going to give us what we want. And I'm going to do the same thing. So I'm not going to really show any work. I'm just going to do the multiplication. So 2 times 0.6 is 1.2 grams. Letter B, 4.2 times 0.6 is 2.5 grams. Letter C, 22 times 0.6 is 13.2. I'm going to round that to 13 grams. Letter D, 6.9 times 0.6 is 4.1 grams. And then number 12, suppose that 200 cubic centimeters of a saturated solution of potassium nitrate were left standing in an open beaker on your laboratory desk for 3 weeks. During this time, most of the water evaporated. Would the mass of potassium nitrate dissolved in the solution change? I'm going to put 12 right here. So here's the equation. Solubility is mass divided by volume times 100. If the volume goes down, to keep this the same, because solubility is going to stay the exact same, it's going to stay a saturated solution. If some of the water evaporates away, then some of the mass has to come out of solution too. So there's going to be a bunch of solid left on the bottom depending on how much water dissolves. So would the mass of potassium nitrate dissolved in solution change? The answer to 12A is yes. And then letter B, would the concentration of the potassium nitrate solution change during the 3 weeks? No. It's going to stay saturated. So whatever the solubility is, it's going to stay at that number. So even though the water is decreasing, the amount of mass that's in solution is going to decrease too. So the solubility for potassium nitrate is about 30 grams per 100 cubic centimeters at room temperature. It's going to stay at 30 grams per 100 cubic centimeters that entire time until all the water's gone, and you're just going to be left with solid.